here's my drawing of the solar system. I wish I could put it in motion for you, all the little moons and everything. Can't do that, just too much to ask. But I think you know the orders of the planets. I don't have to label all of them and junk up the picture that way. Overall, what I want to say here is a couple things. Number one is that it's really big. I mean, duh, right? But before I get into that, before I say it's really big, I need to label. I do need to label a couple of things here. So you got the inner. What are the inner planets? Okay, the inner planets. Okay, Earth is one of those. They're known also as and we're going to be using this term more often, the terrestrial planets. That's Mercury, Venus, Earth, and Mars. Okay. The terrestrial planets you have there are known also as the inner planets, the inner solar system. Okay. And then you have the outer planets. That is, I'll say more about this in just a moment, but these are also known as the Jovian planets. Okay. So there are 4 of each. 4 in each category. All right. And between them, the inner planets here, or terrestrial planets, we'll say more about why it's called terrestrial and Jovian in a minute. So the terrestrial planets here, and then the Jovian planets out here, and in between them, you have the asteroid belt. Connect the dots here. Okay, asteroid belt. So then you got your 4 planets, terrestrial planets, asteroid belt, 4 outer planets or Jovian planets, and then you have this thing. This is less well known, but this is what I was referring to in video number 29. This is the Kuiper Belt out there. Okay, so it's kind of a simple, kind of harmonious, kind of symmetric layout. 4 terrestrial planets, right? Mars, Venus, Earth. Mercury, Venus, Earth, Mars. Then you have the 4 outer, then the asteroid belt. So 4 terrestrial planets, asteroid belt, 4 Jovian planets, and then the Kuiper Belt. So the asteroid belt is in here, and the Kuiper Belt is out there. 2 belts, 8 planets, 2 groups, 4 in each planet. Mercury, Venus, Earth, Mars are terrestrial planets, and Jupiter, Saturn, Uranus, and Neptune are the outer planets, the Jovian planets, and then the Kuiper Belt comes after that. Okay, now this whole thing, like I said, let me go back to this now, is really big. From the Sun to the Kuiper Belt, let me see what color I should use for this, maybe pink. From the Sun out to the sort of the main part of the Kuiper Belt is about 50 AUs. So the Kuiper Belt is 50 times further away from the Sun than the Earth is. Okay, sounds big, right? So the whole solar system, actually, as we'll see, there's more out here, but I couldn't draw it. Shh, there's more out here. But this is sort of the main solar system. It's about 100 AU in diameter, right? If it's 50 AU in radius, it's 100 AU in diameter. But still, as big as that, now you could put about 2.5 million Earths across it. You could light up across the whole thing. So if this is the Kuiper Belt and the Sun in the middle, you could fit about 2.5 million Earths across the whole thing from one end of the Kuiper Belt out to the other. Okay. So in this picture here, Neptune's orbit would be about right there. Kuiper Belt's beyond that. I use blue because Neptune is so very blue. So the Kuiper Belt's about 100 AU in diameter. You can put about 2.5 million Earths across the entire solar system, across the Kuiper Belt from one edge of it to the other. But still you would need about 4,500 Kuiper Belt diameters to get to the closest star. Okay. So as big as this is, it's super tiny when compared to the distances between adjacent stars. Okay, the solar system is pretty much a system unto itself. The closest thing is still 4,500 Kuiper Belt diameters away. In other words, you could put 4,500 solar systems between ours and the closest star, lined up out to the Kuiper Belt. 4,500 of our solar systems all lined up to get to the nearest star. So that's the basic layout. What I want to do though is emphasize to you that these two classifications of planets really are different. Okay, I'm not going to write these on the board. It'd be a little bit tedious, and these are all in your textbook. Okay, so I'm not going to write these out on the board. There wouldn't be really any point in doing that. They're all in your textbook, and I'm just going to mention a few of them. A few of the big differences. Again, this is comparative planetology. Now we're going to compare the inner planets to the outer planets. Okay, the terrestrial planets, the inner planets, okay, are called terrestrial planets. They are all close to the sun and close together. The average distance between them is maybe 0.4 AUs. Okay, something like that. 0.4 AUs is the average distance between them. Maybe more like 0.3. Closer to 0.3 AUs is the average distance between them. So they're closely spaced, okay, and the outer planets are very greatly spaced apart. They have large spaces between them. The average distance between outer planets, Jovian planets, is something like 8 AU or something like that. Okay, but all the inner planets are packed within 1.5 AU of the sun. 1.5 AU, that's all four are within that distance. But then you have an average of 8 AU between these outer Jovian planets. Jovian because of Jove. Jupiter is the is sort of used to name all of them Jovian. Okay. And terrestrial is because of this. All the terrestrial planets you can walk around on. There's a surface. You could, in principle, go to Mercury and walk around on it. It might not be too good for your health. A lot of radiation up there, close to the sun, kind of intense, but you could go up there and put your boots on the ground on Mercury and walk around. Same with Venus, although you wouldn't last there either. You die instantly pretty much on Venus for reasons that we'll see. It's enormously unpleasant, okay, the conditions on Venus. You would not want to take a vacation to Venus. Okay, and you can also, of course, walk around on Earth. You can walk around on Mars. But this is another big difference between the two. The terrestrial planets have rocky surfaces. You can walk around on them. The outer planets, the Jovian planets, do not. They're big balls of gas. Just big balls of gas. If you tried to step on Jupiter, you just fall right through it. Eventually, you'd melt and stuff. You wouldn't really have a pleasant trip. But there's no surface on Jupiter. You can't go walking around on Jupiter. You can't do it. Same with Uranus, same with Neptune, same with Saturn. Can't do it. They're big balls of gas. The terrestrial planets are very dense. Okay, they're made of rocks, but because the outer planets are made of gas, they have very low densities compared to the terrestrial planets. The terrestrial planets have weak magnetic fields. Ours is by far the strongest. The Earth has the strongest of all the magnetic fields of the inner planets. But the outer planets all have magnetic fields far larger than the Earth. Okay, it's another difference. They have huge magnetic fields out there. In here, inner solar system where we live, they have weak magnetic fields, or none at all, as in the case of Mars and Venus. The inner planets have very few moons, right? Remember, there's only 3. Among the 4 inner planets, there's only 3 moons. 2 of them are captured asteroids. but still there's only 3 moons among all 4 inner planets, and all the rest, so that leaves 202 moons among the 4 outer planets. So lots of moons out there, very few moons in here. The terrestrial planets have no rings. Right? Like Saturn, I even drew Saturn's rings because they're so impressive. We'll definitely talk about Saturn's rings. Saturn's rings are so impressive, but it turns out that none of the inner planets have those, but all of the outer planets do. Even Uranus, even Neptune, even Jupiter, they all have ring systems. They're not as bright and famous and showy as Saturn's rings, but they have rings, and the inner planets do not. Finally, the inner planets, the small ones, tend to rotate slowly. Okay, the smaller planets tend to rotate slowly. They have relatively large rotation periods. Okay, so they rotate slowly. That's what, remember, if it's rotating slowly, that means it takes a long time to go around to rotate once, which means it has a large period. Large period means slow rotation. Small period means fast rotation. The outer planets have much faster rotation rates than the inner planets do. Okay. So that's the overall layout. One last thing to say is that all the planets, if we look down on the solar system from above the Earth's North Pole, they all move in the same direction. They all move from above the Earth's North Pole. All planets move in a counterclockwise sense. Okay, all of them. Am I actually going to sit here and complete all these arrows? Wait and find out. Looks like I might. So they all go in the same sense around the sun. Okay, counterclockwise as seen from above the Earth's North Pole and the sun's North Pole. Did you know the sun has a North Pole? It's true, it does. Okay, and they all move in approximately the same plane, the plane of the ecliptic. Only the sun is actually in the plane of ecliptic. That's how the ecliptic plane is defined. All of the other planets, okay, have a little bit of a tilt relative to the ecliptic. The largest is Mercury, the innermost planet, has a tilt of about 7.5 degrees relative to the ecliptic. But for the most part, they all orbit in the same plane. Okay. In other words, there's none that are coming way out of the board here, right, and going back inside and so forth and so on. Okay. So they all would, in this picture, they all stay roughly in the board. Some come a little bit above it, some go a little bit inside of it, but most they stay pretty much in the plane of the board. So that's the overall layout. Let's see what's up next. Next up, tomorrow, the Earth.